Welcome to an Achieving Science video. This video is all about the Haber process. The Haber process is about making ammonia. So let's look at what's needed. First of all, ammonia. Its formula is NH3. This means that it contains nitrogen and 3 atoms of hydrogen. So what is required? Well, we need the raw materials. We first of all need nitrogen, which is achieved from the air. We also need hydrogen, which is achieved from natural gases such as methane, which is reacted with steam. The reaction then can take place within a sealed vessel. This then allows unreactive gases to be recycled, therefore reducing cost and reducing the requirement of resources. So the reaction is said to be reversible, and therefore we can summarise this by the equation. Nitrogen plus hydrogen forms ammonia. And we can see that we've got a forward and backward arrow, which means it can go backwards and forwards. So the nitrogen and hydrogen can react to produce ammonia. At the same time, ammonia can break down to produce nitrogen and hydrogen. The symbol equation for this is N2, which is a gas, so given the symbol G in brackets, plus 3 lots of hydrogen produces 2 lots of ammonia, all of which are gases, and that's important later on. During this reaction then, ammonia is formed, but also breaks down to hydrogen and nitrogen. Therefore, the conditions. Well, first of all, the first condition is that this reaction takes place at 450 degrees Celsius. It takes place with 200 atmospheres of pressure. It requires an ion catalyst. As all of the reactants and products are gases, we need a way of separating them. This is done by the ammonia that is formed being cooled. Therefore, the liquid is formed as the gas cools. This therefore allows the liquid ammonia to be taken away. Now let's go through the conditions. If you remember, this takes place at 450 degrees Celsius. This is because the forward reaction, where the nitrogen and hydrogen react together, is an exothermic reaction. The backward reaction, where ammonia breaks down to form nitrogen and hydrogen, is endothermic. So which reaction is therefore favoured by a higher temperature? The higher the temperature will actually favour the reaction where ammonia breaks down to produce hydrogen and nitrogen, because it is an endothermic reaction. So the hotter the surroundings, the more thermal energy it can take in. But if we used a lower temperature, would that be any good? Yes, we might get a higher yield of ammonia, but there might be a problem. That problem being that at lower temperatures, what happens to the rate of reaction? Well, we know from previous experience, at a lower temperature, the particles have less energy and therefore travelling slower. Therefore, there are less collisions. Particles can also have less activation energy, so the reaction doesn't necessarily even take place. So temperature is vitally important. Too high a temperature, and actually the ammonia that is formed breaks down, but too low a temperature means that the reaction doesn't take place quick enough for us. The rate of reaction is much too slow. Therefore, the solution is that we have a compromise, and that compromise is 450 degrees Celsius. Where the yield is high enough and the rate of reaction is fast enough. Secondly, let's look at why we have 200 atmospheres. The first reaction is the forward reaction, which involves 4 molecules of gas, 1 of nitrogen and 3 of hydrogen. The backward reaction involves just 2 molecules of ammonia. Which reaction is therefore favoured by a higher pressure? The forward reaction consists of 4 molecules of gas and therefore is favoured. The more molecules of gas, the greater the pressure. So the higher pressure would actually benefit the reaction because it would generate a higher yield of ammonia, the required product that we want. But there is also a problem. As well as increasing the rate of reaction, in order to achieve a high pressure, we actually have to have large expenses because the vessel walls need to be so thick to be able to withstand the high pressures, that therefore we need to have a compromise again. So a compromise is reached of 200 atmospheres because this is deemed to be the right amount of expense in order to build the vessel. Finally, why an ion catalyst? Well, catalysts make the reaction go faster. How? Why? Well, the catalyst does not change the amount of product or reactants. Instead, it lowers the activation energy, so the reaction can occur at a lower temperature. This means that when particles collide, in order for a reaction to take place, they need to have enough energy. The enough energy is referred to activation energy. So if a collision can happen with particles colliding with less energy, then this is beneficial.